Is this an alternating series? Question answer is?
Heck no.
Correct. Why not?
Squared.
Therefore, it's
It's positive.
this one we can't apply for. It's really the same as k to the 2k. Yeah? Or k squared to the k. I don't know what this one does. So k is 1 and 2 and 3 and 4 and 58,000. This series clearly what? Clearly. You could use the divergence test on this one. What was the divergence test? One of the first ones that we learned, yes.
If the limit of the series does not approach 0, then it diverges.
That's correct. So that was an easy one, yes? It sort of looked like it might be alternating, but in fact it's not. Look at the next one, B on it. Is that an alternating series? Yes or no?
Yeah. I think so.
That would be the wrong answer. What kind of an exponent is 2k plus 1 all the time? Yes. Louder?
Odd exponent.
Certainly.
Oh, it's always odd.
So if it's always odd, then what's true of the sign of all those terms?
Negative.
Alternating. In fact, it's just the negative of k squared. So the series is 1 squared plus 2 squared plus 3 squared plus 4 squared. Same as the last one, clearly diverges. Harish?
No.
And we'll go to the last one, C. Strictly alternating?
Depends. Yes, it is strictly.
So, satisfies the first condition, it's strictly alternating. How about the second condition? Are the terms getting smaller and smaller? Answer? 2 words?
No.
And therefore it diverges. So we don't even know what it is. At least it doesn't pass the alternating series test. So those first examples didn't satisfy the conditions. Let's look at question 2. Yes, Ruth?
So, if you're using the alternating series test, and if it fails, it by default it diverges,
No,
or no?
we really can't draw a conclusion.
Okay, no.
But this one is going to diverge, this last one, because think about it. Your terms are all even numbers. Can you see that? Ruth?
Yeah.
So when k is a 1, it's plus 2 take away 4, plus 6 take away 8, etc. and so forth. It's not going to converge on a particular value. You're essentially going to be adding -2, -2, -2. Yes, Ruth?
What is the last rule?
The limit as k approaches infinity has to go to 0 of the kth term.
Oh.
So that next one, question number 2, I gave you a general term for it. If you look, you see the general term. Yes or no, is it strictly alternating?
Yeah.
Could the rest of you join in the lesson so it's not just me and Ruth?
Yes.
Thanks. Is it decreasing, or at least non-increasing?
Yeah.
Yeah.
So far, so good. Is the limit tending towards 0 for the kth term?
Yeah.
Yes.
And that's all you got to do. This series converges by the alternating series test. It passed all the necessary tests. Make sense? Yes.
I don't understand the difference between decreasing and approaching 0.
So I can have a series that gets smaller and smaller and smaller, but kind of flattens out at 10
How can you tell this?
by taking a limit. I can have a series that gets smaller and smaller, but it's never going to get anything lower than 1/3. It's not going to pass this test. If I take the limit and I find the limit is 0, that's the one I'm looking for. I want to get through that next example and then get to that little chart there that will cement this in place and make sense to you. So we're looking at that question k plus 3 over k times k plus 1, yes?
Yes.
See if it satisfies the conditions, please. Is it strictly alternating?
Yeah.
Is it non-increasing?
Yeah.
Is the limit 0?
Yeah.
So that limit should have been pretty quick. You see there's a k to what power in the numerator?
First.
Second power in the denominator. It's going to tend to 0. Yeah?
Yes.
Make sense?
Yeah.
Yeah.
I'm going to use a strange notation here. You have the picture already in front of you, but I want you to follow what's going on. Let's say this is an x. I'm making up a number 2. The first term is 2. The sum of the first one terms is 2. The same number, yes? And I pick a positive number. If I'm now going to add a negative number to it, because it's going to be alternating, I should travel which way?
Left.
So I'm going to say, I'm going to travel that far, and that's the value of a sub 2, which is going to make the value of the sum, wherever it was there, right over here. That would be the sum of the first two. Whatever that sum was, plus that negative number, I get the second sum. Make sense? I'm now going to add the third term. What's its sign going to be? It's going to go which way?
Right.
So I'm going to travel, let's say a sub 3. You notice each time I'm going to do this, I'm going to add a smaller number in absolute value, because that's a necessary condition. So there's a smaller number in absolute value than this was. And of course this becomes the sum of the first 3 terms. Let's do one more. The fourth term is going to have what sign?
Negative.
Going
Left.
no. Let's say that's a sub 4, and that would be the sum of the first 4 terms. Somewhere inside here is the final sum. It's between the first and the second, between the second and the third, between the third and the fourth, because we keep going bigger and smaller and bigger and smaller. Making sense so far? I'm going to indicate somewhere over here is the actual sum of these terms. They get us to something. There's an important concept here, and that's the following. If I said s sub 3, that's close enough to the sum. I'm happy with s sub 3 as my sum. How far am I off? By this much. Can you see I'm off by less than the fourth term?
Yeah.
I'm inaccurate, away from the actual sum by less than the fourth term.
Yeah.
Another one. Suppose I added a fifth term. Notice I have to stop before I get to there, because the fifth term's got to be smaller than was the fourth term. And that's the sum of the first 5 terms. Let's say I said s sub 4. I think that's close enough. My error is less than whatever the fifth term was.
Yeah.
So if you take the sum of the first 4 terms as your sum, then the error is less than or equal to the absolute value of the fifth term. If you take the sum of the first 20 terms as your sum, then the error is less than or equal to
21st. After that, after the 21st.
whatever the next term was. That's really the concept I wanted you to see here. And if we look at the series, question number 1 minus 1/2 plus 1/3 minus 1/4. It sort of looks like the what series, except that it's alternating. We know the harmonic diverse, but this one we found converse as an alternating series. Yeah? If I said, you know what, the first 3 terms is good enough for my sum, the error would be less than 1. It would be. If I said, nah, I need the first 4 terms, the error would be less than
1/5.
So you're going to be asked to find the error term. And there's nothing, it's really simple. Just look at the number of terms they want, maybe actually add them up, say this is my sum, my error is less than whatever the next term would be.
Why do you always go to the one before? Why can't you say from S to S sub 5 is less than the value of A sub 5?
Okay.
So why is the rule you
This
go?
is the error. If I say this is the sum I'm going to accept, it's not correct. It's off by that much,
Which is less than.
which is less than that.
So why do you go to S, like the sum of before?
Okay, 1 second. Maybe I drew it better on this for you to see better. Okay, I did. Look at the diagram in front of you. Do you see where S sub 5 is?
Yeah, S sub 6 is closer, is that why?
Yes.
Okay.
You see where S sub 3 is? S sub 5 would be much better than S sub 3.
So why don't you say S sub 6 is.
I know S sub 6 is off, but I don't know by how much. I'd have to draw an S sub 7 to see what the error is for S sub 6.
Okay.
I'd have to look at the next term. Yes.
When you said the error of the first three is less than, is it less than or equal to?
Less than or equal. It's always less than. But we write less than or equal. Really, it's truly less than. It has to be less than.
Then why do we write? Should we write equal to or then?
Let's write just less than. Okay. Which question am I doing? Let me see this question. So can somebody tell me the sum of the first 4 terms here? Feel free to do it by head or the calculator's up to you. Easy approach is a half minus 1/12, plus 1/12.
7 tenths.
So that's a sum. It's not perfect, but it's off by.
Less than.
If you wanted to find what we call a percentage error, percentage error is usually the amount of the error over the original amount.
Yeah.
So the amount of the error we know is less than
Less than.
1/5.
No, 1/5.
I was thinking this was
That's it.
So 1/5 divided by the actual sum, 7/12, that could be converted into a percent. It becomes a 12 over 35, and whatever percentage it is, 16, about 16%. That's a pretty big error, 16%. Yeah? Yes?
I'm sorry, where's the fifth coming from?
The error is less than the next term, which is
The
1/5.
next.
And the absolute value.
Okay, thank you.
So if we wanted to be more accurate than 16% error, we would just have to do what?
Get more sun.
Do it again.
So, and we could get the error down to whatever we want, actually, just add a few more terms, check the error, and by finding the sum, finding out the error, let me write that over here. Error over sum gets you the percentage.
I just got 34%, not 2%.
For this one,
Yeah.
34% of what I just said, sorry. That's even huger.
It's a lot worse.
Horrible. When did I get 60? I think I added 2 more terms because it looks like my error was 1/8. So if 1/8 is the error, I must have added up.
7%.
So again, you can get it better depending on how accurate you are. What if the error, like these errors are too big? We want the error to be less than 0.01. Which is 1%. 1.01. If we wanted, let's get error, let's think 0.01, or let's say less than or equal to 0.01. Do you know what the error term would be? Let's say it's less than or equal to 0.01. The error term would have to be what?
1 times the
Just the error term. In this case, 1/5 was the error term.
you're saying in this case? Or general.
For this, what would the error term need to be?
1 over 100.
Yes. If that was the error term, then we need the sum of the first how many terms? Whatever that sum would be accurate to within 1/100. See it? The error term is the next term. Let's look at an example, and we're almost done with the whole lesson. -1 to the k plus 1 over n factorial, that must be k factorial, k equals 1 to let's write out this. Wait, what's the first term?
1 over 1, just 1.
Second term.
Minus 2. 1 over 2.
Let's write 2 factorial. Next term.
Minus 1. Plus 1 over 3 factorial.
You get the idea?
Yeah.
So, if I want the error when k is 5, let's first find the error when k is 5. Can you tell me the error term when k is 5? It should be easy. You should be raising your hand.
1 over 6 factorial.
Yes. Say what again. Is anybody not getting this? Is anybody getting this? It's always the next term. So when k is 5, it'll be a 5 factorial, the arrow will be the next term.
How do you get 5?
I made it up. I said when k is 5. What would be the error term?
Oh, okay.
So, what is that error term?
Now you want the error percent?
No, first just tell me its value.
Oh,
Return 1 over
1 over,
6.
1 over,
1 over 6 factorial.
can't hear you?
720.
7
Why are you going with this?
720.
1 over 7.
So, that's the error term. If I wanted it as a percentage error, you would have to actually find the sum of the first 5 terms. I'm not going to do that, but you could do that, couldn't you?
Yeah.
And then we could turn it into a percent if we wanted to, yes? I'll show you something on the calculator. Suppose we wanted the error to be 0.0, less than or equal to 0.001. Let's come up with a practical way to know what k would have to be for that to be the error.
That's the error term.
That's the error. You could just think about this in terms of, so 1 over 6 factorial is this. What's this as a decimal? Calculator?
Oh,
0.0013888.
Way too gigantic, yes?
Yes,
You
yeah.
might do this by trial and error. So what might you try for an error term? I'll try 1 over 7. This is so far off you probably could skip a few. I don't know.
That's the error term. The one
This is the error term
Right.
when k is a 5.
No, I'm talking about the 0.01 over
I don't know for what this is the error term. I need for you to figure it out. So you might try 1 over 8 factorial. Let's see. What's 1 over 8 factorial?
40,320. 40,320.
1 over 8
over
factorial
2.48 times 10 to the minus
minus 5. So that's 1, 2, 3, 4, and 2 point something.
Yeah. Ooh.
So it's just a little too big, yeah?
7.
Yeah.
This is not less than or equal to this, but we're in the neighborhood, yeah? We're trying out error terms. Once we have the right error term, we'll know how many terms we needed, yes? We'll know for what value of k it will be accurate to this degree of accuracy. So what are you going to try?
Nine.
Please tell me, does that work?
It's too big. Oh, well,
Oh,
that
it's too
works,
small.
yeah,
Does that work?
yeah.
Yeah.
So 1/9 factorial turned out to be less than this, and that means the sum of the first 8 terms will get us an answer, whatever that is, to a degree of accuracy that we're happy. How many understand that what we just said? This could be accomplished using your calculator, even though it seems like it's going to take a long time, using some sequence. What would be the general term? Yes.
The equation.
Yes. So you have to actually write -1 to the power x plus 1. I screwed up, but I do.
Parentheses.
And you parentheses on the numerator.
No, you know. Divided by k factorial. I just made a mistake.
Parentheses. Yeah.
Yes. Oh, sorry. It's going to be x factorial. Let's stay with one letter. Comma with respect to x. As x goes from
One
to
infinity.
no.
Okay.
Yes, thank you. Remember, we're looking for a sum of the first 8
Yeah.
terms. If you don't put another increment number, it will increment by 1. It'll do factorial and 2 factorial, yes.
How come sometimes you have the sequence x and then comma x again? Are you supposed to two x's or one?
We always have with the complex.
No, but sometimes there's like two, no, like two
If the
x's.
function itself is just x, then it's just x.
Oh,
But this function is a little more complicated than just x. So if you were to type this into your calculator, it will give you the sum of the first 8 terms. And in fact, can somebody do that, please?
what increment? You said
It'll
you,
increment by 1 unless you tell it otherwise.
so you technically could write a comma 1 after that.
You could certainly write this. So we're all waiting for somebody else to do it? Or for Shlomi to do it?
1632.
1632,
One,
1,
two.
2.
One, 1, 8.
All right, so let's say there's some more places. Anyone verifying it?
Yeah.
Yeah.
So that would be our sum. We said the error was 1 over, what did we say the error? What was that?
10001.
No, that's what we wanted.
What we get of
But
1
what was actually what was the ninth, the error term?
point
Over 9 factorial.
Yeah.
5 O's 2
1,
cents.
1/9 factorial. If we were then to divide the error term by the actual sum, we could turn this into a percentage error as well. Agreed?
Yeah.
So this is the sum, as sub 8. This was the error. This was a sub 9. And of course the error over the sum should get us a percentage error. And you just turn it into a percent. So again, we can get any degree of accuracy that we wish. And that's it. I'll take your questions now on whatever you like.
Multiply by 100 after you get all this.
Turn it into a percent. So, questions? Yes, Ruth?
So sigma,
Can you repeat that, please?
sigma from k equals 1 to infinity. Inverse tan of k over k squared. And converted it on to
Is k squared, you said?
yeah.
So I think this one's going to converge. The reason why I think it's going to converge is because I see that k squared looks like a p series. This doesn't bother me. Yes.
Why it doesn't bother you? Because it's only the first one, and after that.
What do you mean it's only in the first one? What is it?
Oh, actually, I was confusing it for geometric form. I was-
Inverse tan of a number doesn't bother me. That's,
Because it's just a number.
It's not that big a number.
Zero, five,
No,
zero, two. Or
No.
negative 2.
Five or two.
Five or two. Oh, one of those.
so it's a number, that's where you have to know the principal range is. Every time you see it, it's gonna be for the principal range. So it's a number between minus pi over 2 and pi over 2. Over this gigantic number, this k squared, it's starting to look like a series of converges. Ready? So if you think it's going to converge, which you do, you want to create a series that is blanco. Blank. So let's think about between minus pi over 2 and pi over 2. Pi is around 3-ish, so it's around between minus 3/4 and plus 3/4. I'll just make up a number like 10. It's bigger. 2. 2 would be good. 58 would be good. So I'm creating a series that for sure is bigger, converges, no question, as a p-series. Therefore, the original converges by the comparison. Yes.
So you just subtract them, you
I
subtract.
did not subtract anything. I replaced that numerator with my own numerator.
It could be anything.
I don't know what you just said.
I said it could be anything.
It can't be anything. I couldn't make it 0.1, because I can't guarantee that 0.1 is bigger than this.
Oh, okay.
The 2, for sure. Yes.
I have a question. It's square root of k over k cubed plus 1.
So the rule of thumb, remember, you could ignore you could ignore any constant.
Correct.
If I ignore the constant, this looks like k to the 1/2 over k to the 3,
Which is like part.
which is like 1 over k to the 5/2. Yes. Which verges? Pick a verge.
Converge. That's what I did.
So this one is likely to converge. Now the question is, can we simply write one without the 1? Is that going in the correct direction? Converge, we want to create a bigger one. Therefore, a bigger one, we want to make a blanker denominator.
Smaller.
So it's taking away one convenient.
Yeah.
So we show that here. That's what we're doing to engineer this new one. And then we're just writing it, having reduced it to something that's clearly converging as a constant. Make sense? Next question. Great.
Just writing one thing. Okay. So it's probably the easy one. The sum of from 1 to infinity of 1 over 3 to the k plus 5.
Down here?
Yeah. Just never know what to add.
So there's only 2 principles.
Yeah.
Only one of them can be applied here. Which one?
Geometric third.
Which principle?
Oh. The first one.
Which is?
That you could take out all constants.
It's not we're taking it out. We're
Yeah.
ignoring.
Okay.
It's there.
Yeah.
So 1 over 3 to the k looks like a what?
Geometric
The kind that converges or diverges?
converge.
So this one's probably going to converge again.
Yeah.
Same business as the other one. It's convenient to take away the 5. We'll do the same thing we did on this one. Except this one,
You need to take away the 5. I thought we want the other one to be bigger.
we do. Making a smaller denominator by taking away 5 makes
Smaller
it bigger.
denominator.
Next question. Yes.
So, sigma,
Yeah.
1 over square root of,
Might want to turn that thing around.
hold on. Yeah, what was, you could copy the Ross.
I have it. Which one was it?
21. So 29.
You want me to ask
Get rid of k squared plus k.
Excellent.
Okay. So this would be the second principle. And that would be we ignore over the highest power of the variable. If you did, what's the square root of k squared? 1 over k.
Oh. I'm like,
It's likely to. That's correct. So in this question, since we think it's going to go, we need to create a series that is
smaller.
by doing what to its denominator?
added.
All students still thinking about developing a science project are advised to see me today,
Something that
either
carries the
period
wrong
10
direction.
or during club time in the computer room.
Yes, very good.
Oh,
So
okay.
essentially,
Gina Capito, please come to the office.
replacing that plus k with a plus k squared, making a bigger denominator, creating a smaller fraction. And now
Enter Brown to college guidance, please.
which is the same as 1 over square root of 2 times k, which is a type C.
Sammy Whitkus and Hannah Schwartz.